Hi there, it's Katie with TutorPUG, and I am going to run through 3 quick, difficult examples of partial derivatives. If you are not well versed in these, if you feel a little rusty on your derivative skills, go back and watch one of the earlier, sort of easier sections, and then see if you can tackle some of these. So, first of all, I've got f of xy, x to the 10th, 9 to the y, minus 6x minus 7y to the 5th plus 8 over x. So I need to find f sub x and f sub y. So I'm going to start here on this first term. It has an x. The x portion will be derived. All the other pieces will come along with it. 10x to the 9th, 9 to the y. Next term, it has an x. It needs to be derived. It has a chain rule. So I will keep the inside parenthesis statement the same while the outside drops and flops. And then I will multiply by the inside, the derivative of the inside with respect to x. And my last term, I can think of that as 8x to the negative 1. When that gets derived, the negative 1 drops down, and I have negative 8x to the negative 2. Now I'm ready to do f sub y. I go back up to the beginning. The first term has a y. The y is in the exponent location. Everything else just trails along. The derivative of 9 to the y is 9 to the y times the natural log of 9 times the derivative of 1y, which is just 1. Next term has a y. It's also a chain rule. I keep the inside the same while the outer drops and flops. And now I multiply by the derivative of the inside with respect to y, which is negative 7. The last term does not have a y, so it will disappear. His derivative is 0. It's a constant, it goes away. Here's my second one. Now I've given us 3 input variables, a, b, and c, so I'm just going to have 3 separate partial derivatives. My first one will be g sub a, so I'm deriving with respect to a. First term has an a. It has an a raised to the b power, which means a is the variable, b is acting like the constant or the number. So think of it as, if you want to, think of it as a to the 3rd. So if you have a variable raised to a number, when you derive it, the number drops and you subtract 1 from it, whatever that number is. So in this case, the derivative of a is b times a to the b minus 1, and the c to the 7th just comes along as part of the ride. My next term, there's the a, that's going to get derived, everything else trails along. So when I derive this a, that 3 will drop down and multiply by that 3. Over here, my a is under a radical, which really means a to the 1/2. So when I derive that a, I get 1/2 a to the negative 1/2, and everything else acts as a coefficient, so it comes along for the ride. And my last term has an a. Now the a is the exponent. When the variable that you're deriving with respect to is the exponent, it becomes that number to the blah rule. So this derivative is going to be a recopy of the original term times the natural log of the value that is the base of a. Little tricky, but you'll get the hang of it. Now I'm ready to do g of b. It has a b. The b is the exponent, so it's going to behave like this guy did over here. That will be a to the b times the natural log of a times c to the 7th, just trundles along. This has a b. When I derive that, the 2 will drop down and I will have this guy has a b. It's the natural log of b. So I'm going to recopy all the other pieces. And the derivative of the natural log says you take that argument, you put it in the denominator, you derive that denominator, and you put it in the numerator. And then my last term has a b in the denominator, which is really a b to the negative 1. So this guy can be thought of or rewritten as c to the a times b to the negative 1 if I want to bring that out of the denominator. And that derivative becomes negative c to the a b to the negative 2 because the negative 1 drops down and subtracts 1. My last one is g of c. C gets derived, everything else comes along, so that would be 7ab c to the 6th, because I'm just dropping that number down and putting him in the front, sort of as convention. Here's my c. The 4 will drop down. Now I have a c in the denominator. So he's going to behave like this b did. It's c to the negative 1. So that would give me negative root a natural log b c to the negative 2. And over here, I have c to the a over b. C is my variable. So this will be a c to the a minus 1, and the b just trundles along. That's a whole lot of math, but those are your partial derivatives for some fairly difficult starting problems. Practice as many of these as you can, and you will get the hang of it. Happy mathing!